Welcome to Triangulum Trek's Field Notes in Astrophysics. This episode covers features of the galaxy M33. Find more episodes on our Triangulum Trekker 33 YouTube channel. You can also find links to these videos on our website, triangulumtrekker33.com. I captured the image of M33 for this presentation with my Celestron Origin telescope. M33, or Messier 33, is also known as the Triangulum Galaxy due to its location within the boundaries of the Triangulum constellation. M33 is about magnitude 5.7, but its surface brightness is low due to its extent. It is reportedly visible to the unaided eye under a dark sky, in fact at about 2.9 million light-years away. It is one of the most distant objects we can see without optical aid. I, for one, would still need corrective lenses under the best circumstances. Have you seen M33 with the unaided eye? Tell us about it in the comments. You will notice M31, the Andromeda Galaxy, not so far away on the sky. Well, M31, our Milky Way galaxy, and M33 are the three largest galaxies in the local group of galaxies. The Triangulum Galaxy has around 40 billion stars, the Milky Way 10 times that, and the Andromeda Galaxy about 1 trillion stars. The Andromeda Galaxy is not only more massive than the Triangulum Galaxy, but at 2.5 million light-years from us, it is also significantly closer. M31 and M33 are about 750,000 light-years distant from each other, and the two seem to be at least loosely linked. In addition to the number of stars, the diameters of the galaxies, here in thousands of light-years, differ. All three galaxies are spiral galaxies, but unlike M31 and the Milky Way, M33 does not have a significant bar structure at its center. A more complete classification of M33 indicates it is a spiral galaxy with no central bar, with loosely wound arms that emerge from the galaxy nucleus. The arms are readily visible to us since the galaxy is nearly face-on from our perspective. Unlike M31 and the Milky Way, M33 does not have a supermassive black hole at its center, perhaps because it has no bulge. The inset here shows M33's central region. Okay, great. So what features can we see within M33? First, we can see H2 regions of ionized hydrogen associated with star formation, here underlined in red. The brightest are in M33's center and its spiral arms. For analog regions near Earth in the Milky Way, consider the Orion Nebula, with its association of 4 young stars known as the Trapezium, the Lagoon Nebula, and the Eagle Nebula. NGC 604 is the brightest of M33's H2 regions. Indeed, it is the second most luminous H2 region in the local group, about 45 million times more luminous than our Sun. As an aside, do you know which is the most luminous H2 region in the local group? For the record, it is not in one of the 3 largest local group galaxies, but it is in a satellite galaxy of the Milky Way. It is the Tarantula Nebula in the Large Magellanic Cloud. About 200 hot, massive stars at the center of NGC 604 reflect an episode of star formation about 3 million years before the time observed. NGC 604 is more than 6,000 times more luminous than the Orion Nebula. It would certainly be a remarkable sight viewed from the Earth to Orion Nebula distance. Here are a couple close-ups of two of the other H2 regions, NGC 595 and NGC 592. NGC 588 IC0132 and IC0133. We can also identify some star clusters in M33. M33 has relatively few globular clusters. I have added GC after the names of two of M33's true globular clusters. Examples of star cluster types in the Milky Way. Consider the globular cluster M5 and the open cluster M44. C39 is a cluster that is also associated with M33. Can we see individual stars in M33? Yes, we can. The brightest is B324, an A-type hypergiant. 110A is a star a bit farther from the center. I have not included WR14 because it is just off the field to the lower right, but that gives an idea of the spatial extent of the galaxy. So we were able to image and identify multiple H2 regions, star clusters, and even individual stars in M33, about 2.9 million light-years distant, and learned about some of the characteristics of this local group neighbor. Scott Harrington's article from the November 2024 issue of Sky and Telescope was quite helpful to me in the preparation of the clusters and stars sections of this presentation. I hope you enjoyed this video. Explore further with my poster featuring images of all 110 objects in the modern-day version of the Messier catalog, available on Amazon. If there is sufficient interest, I will design more posters addressing additional topics. More videos and images about the sky and the equipment I use are available at triangulumchecker33.com. Thanks for watching.